Alrighty guys, let's go ahead and tackle these acceleration math problems. First thing we are going to start out with is recognizing what the formula is. So we are going to be looking for the final speed, or the velocity final, subtracting the velocity initial, so your initial speed, divided by the total time that is involved in that math problem, okay? So let's jump on down here. After 30 seconds, a runner is sprinting at 3 meters per second, but 10 seconds later, the runner is sprinting at 3.8 meters per second. What is the runner's acceleration during this time? So during this 10 seconds, what is his acceleration? Okay? All right, so what I like to do is I like to draw it out. So I've got my line here that I'm going to be plotting. So I have speed on the top and I'm going to have time on the bottom. Alrighty, so I know from my story problem that at 30 seconds, my runner was going at 3 meters per second. Okay, so I can verify that at 30 seconds, my runner was at 3 meters per second. But 10 seconds later, well, so I know then that 10 seconds later, that is going to be 40 seconds, right? Because my previous time was 30 seconds. So add 10 seconds to that. I am now at 3.8 meters per second, okay? So I'm going to verify that up here. So I'm at 3.8 meters per second, 10 seconds later, which is my 40 seconds, all right? So now what I am able to do is I'm able to plug in my numbers. So my formula for average acceleration, let's take that highlighter off, is velocity final minus velocity initial over time, okay? So what am I going to plug in? Here was my final. So that's 3.8 meters per second. Subtract off my initial, which is 3 meters per second, divided by the time frame I'm looking at. So what I'm looking at here is 10 seconds. 10 seconds. So then I'm going to subtract that 3.8 minus 3, and that gives me 0.8 meters per second divided by 10 seconds. So far, so good? All right, so we are going to plug that into our calculator, and 0.8 divided by 10, we come up with 0.08 meters per second. That's this part right here. And we can, per second, that's this part right here. We have to include everything. This is not one of those examples where we get to cross off. So we also could write it at we could write this as 0.08 meters per second squared, since there's two of them, okay? So my answer coming up here is 0.08 meters per second, okay? Number 2, a car was moving at 14 meters per second. After 30 seconds, its speed increased to 20 meters per second. What was the acceleration during this time? All right, so let's start to put that on our little line here that's going to help us visualize what we're doing. Okay, so where did I start? My initial speed was 14 meters per second. And then so after 30 seconds, its speed increased to 20 meters per second. 20 meters per second. So the time frame that is told us here is that it is going to increase in 30 seconds. So we could say that this was 0 seconds, and this increased then to 30 seconds. Or we could say that this entire thing was just 30 seconds, okay? So we are ready to put that into our equation. I'll change up my color. Okay, so understanding that my formula is final velocity minus initial velocity divided by time. Here is my final, 20 meters per second. Subtract off my initial, 14 meters per second, divided by my time, which was 30 seconds. Then I put that into my calculator, so 20 meters per second minus 14 meters per second is 6 meters per second, divided by 30 seconds. Absolutely putting that into a calculator, and I come up with 0.2 meters per second from here, seconds from here, or I could say 0.2 meters per second squared. So my answer here is 0.2 meters per second per second. Kiko is coming down on her bicycle, is coasting on her bicycle down a hill. After 3 seconds, her speed is 10 meters per second. After 8 seconds, her speed is 25 meters per second. What is her acceleration during this time? So our acceleration is during this time right here, okay? So let's come down here and draw our line, start plotting out what it is that we are trying to do. Okay, so let's get rid of that. All right, so what do we have? After 3 seconds, her speed is 10 meters per second. All right, so let's come down and put that on our line. And we have our speed is 10 meters per second, and our time is 3 seconds. All right, so now let's look at the last part. After 8 seconds, her speed is 25 meters per second. Let's change that color. And 8 seconds, 25 meters per second. So let's come and put that in. 25 meters per second, 8 seconds. Okay? So go back right now and double check so that you understand where I got those numbers. Now I'm ready to put it in my equation, knowing that I'm looking at my final minus initial divided by the time that this is happening. So my final is 25 meters per second right here. My initial is 10 meters per second right here. And the time frame I'm looking at, 8 minus 3 is 5 seconds. So I'm ready to subtract that. 25 meters per second minus 10 meters per second is 15 meters per second divided by 5 seconds. And 15 divided by 5 is 3. Now I am ready for my units, which is meters per second from here, per second from here. Or I could say 3 meters per second squared. Now, let me back this up to this section right here. What we could have done, I kind of combined a step there. What we could have written out was 8 seconds minus 3 seconds to come up with our 5 seconds. Okay, so I skipped that step. Sorry about that. So our final answer here is 3 meters per second per second. Okay, ready for this final one? Hans's younger sister is riding her tricycle in a straight line. After 3 seconds, her speed is 0.5 meters per second. After 5 seconds, her speed is 1.5 meters per second. What is her acceleration during this time? All right, so let's identify some of the parts that we know. So we're going 3 seconds and 0.5 meters per second. So we're just going to take that on down here, draw our line, and we have 3 seconds. Let's go back up and double check what that time was. That speed was 0.5 meters per second. And then we have our final. So let's change our highlighter so that we can, let's change it to green this time. After 5 seconds, her speed is 1.5 meters per second. All right, so let's come down here and plot that. Put that on our line. Okay, so after 5 seconds, then the speed is 1.5 meters per second. All right, so now we are ready to put this into our equation. So acceleration is velocity final minus velocity initial divided by time frame. All right, so what is our final? 1.5 meters per second. Subtract off our initial, 0.5 meters per second, divided by our time, 5 seconds. Subtract off 3 seconds. Okay. 1.5 minus 0.5 is 1.0 meters per second. 5 seconds minus 3 seconds is 2 seconds. So now I am ready to put this into my calculator. So 1.0 divided by 2 is 0.5 meters per second for here, per second for there. Or I could say 0.5 meters per second squared. So let's come on up here and let's put that in here, 0.5 meters per second per second. So these were all examples of positive acceleration because we went from a lower speed to a faster speed. But if we have it the other way around, where we are having a faster speed coming down to a lower speed, we're decelerating, then you're actually going to have a negative number in your for your answer. So we didn't have any of those today's practice. So hope this helps. I will see you soon. Bye-bye.